First thing is we have to define a node structure. What will a BST node contain? Bare minimum, left, right, and a value. So this is the node structure. So can you all define a class of BST node and call it BST node? Have three things, three fields in this class, and also define a constructor of the class. So this class should have three data members and a constructor. Constructor should be parameterized constructor. It should take value as input. And initially we are sticking to int values, but going forward we will see values can be any type: int, float, char, string. Left and right data type will be BST node. Constructor will have same name as class name, and it will take only one parameter, int val. Inside that we will say this dot val is val. Left and right we can make null, but that is redundant. By default in Java they are null, so we can skip that. So far this is just creation of a data type for every node. If we have to create a node with some value, we will say BST node n is equal to new BST node of any value that we give. Let's say we give 5, so it will be like 5. This will be null, this will be null by default. It will end up creating these nodes. Now we are going to define another class. Let's name that class as BST operations. Now this class will provide us functions which are independent. So I'm going to give you a few requirements. You have to keep those requirements in mind when you are writing those functions. One function that I'm giving you is its return type should be BST node. Function name I'm defining as insert. I'm going to give you a node root, and I'm going to give you a value v, and return the root. Same if r is not modified. You will return same r if r is not modified. New node if r is modified. And we will think of all these things recursively so that we build a better intuition of recursion. So what is the case when root will change? If initially tree is null, that means when I say insert a value in the tree, initially r is null, all you have to do is create a node and return that node. That's all. But if root is not null, imagine there is a tree with only one root, which is 5. Now if I say go and insert 2 in it, so what should we return back? 5 only should return back, but 2 should be there linked to it. So root doesn't change in this particular case, but 2 should be inserted. So if we have to write this as a recursive function, everyone work out and write recursive code of this. Keep in mind, we have to avoid duplicates. Do not insert duplicates. Try writing this function yourself, visualize. But this function should handle every case. If root is null, then also. If root is not null, then also. And even if I give you input which has duplicates, it should not insert the duplicate value. Because we discussed that we are creating BST which will not contain duplicates at all.